Hi, it's Richard from RGM Remaps, and today I'm going to talk to you about battery support units, what they are, when you use them and what not to use. So this is a battery support unit, it's a GYS 100. Compared to a battery charger, a battery support unit provides a stable voltage where a battery charger comes in and out. Let's say a battery charger is generally going to provide 13.5 to 14 volts, but it will charge at 14 volts and then kick down to 12 volts and it'll come and go as a trickle charge cycle. Whereas a battery support unit will maintain whatever voltage you set it to, let's say 13.5 volts, it will just keep a steady 13.5 volts the whole time. If the van or car you're flashing's fans cut in or the lights come on and draw more amperage, the battery voltage will be maintained at whatever it's set at. Whereas a battery charger would just dip down. So if it's set at 13 volts and the fans come in, it might drop down to 12 volts or 11 volts and keep going down. Obviously, a battery booster pack is no good because a battery booster pack is just a battery. Let's pretend you're flashing a vehicle, you put a battery booster pack on and the fans kick in and draw, say, 100 amps. Both the batteries of the vehicles will go flat and the jumper pack will go flat in about 10 minutes. And let's say it's a 20-minute ride, you're going to end up with a dead vehicle and potentially, worst case scenario, needing a new ECU. So battery support units are a must for OBD flashing. So as I said, GYS 100 is probably one of the better ones. Everyone in the industry ends up with one of these because a lot of people start with something cheaper and realise it's not quite up to the job and then get one of these. A minimum for a battery support unit for remapping, you'd want a 50 amp unit, and that will get you through sort of 95% of jobs. It's only things like Mercedes and Bentley that draw like 100 amps. So obviously connect it up, it's just a battery charger in effect. You would just connect it onto the vehicle's battery, press start in battery support unit mode, and that will just maintain the steady voltage there. So that's one way of doing it. The other way is with jump leads off a running vehicle, because most vans have like 150 or 180 amp alternator on them. So they're actually better running on jump leads than they are off a battery support unit. Because ultimately all you're trying to do is the vehicle you're flashing, you're just trying to keep the voltage high because it's going to want to go low because the ignition's on and the lights are on and the fans are on. The battery is going to deplete. Obviously, you're just trying to keep the battery up. So you need to maintain more charge to it than it's losing. If a van has a suitable alternator, which most do, it's just jump leads from your van onto the customer's vehicle is enough to maintain a steady rate of charge. Obviously, it doesn't look very professional having your bonnet open. So what you can do is you can put an Anderson connector, which is one of these, up onto your battery. You would hardwire it onto your battery and you would have that poking out of your grill. And then you'd have a set of leads very much like this that you connect to the vehicle that you're flashing, this end, and then you would plug that into your grill and then start your van up, and then at that point you'll be able to maintain battery voltage. The other option for mobile, if your van doesn't actually provide enough voltage for a vehicle, you could fit your van with an inverter, and then from the inverter it's going to take it up to 240 volts. So you've got a mains plug, at which point you can plug a GYS flash unit in, and then you'd be able to just obviously use this. At that point you wouldn't need to leave your van running because the battery on your van is going to provide enough charge to be able to run the battery support unit to keep the voltage up on the donor vehicle. It's only if you were into a long flash cycle that you'd maybe need to start your van. But most inverters beep when the battery voltage is getting low, so you could just fire the van up and everything's going to work. You could, you don't have to use customer's power supply ultimately, because it may work for a while for you, but you're going to get stuck on a job and it's going to be a long ride and you're not going to be able to, you just failure to prepare is preparing to fail, right? So you just need to be prepared. I would start with jump leads personally. We've used jump leads on vans for years. It's super reliable. In a minute, I'll show you through the two vans we use. One we use a battery support unit and an inverter, and the other one we use Anderson connector in the grill. Both work really reliably. Arguably, inverter and the battery support unit option is potentially less reliable than the Anderson connector in the grill, purely on the basis that the battery support unit could fail and the inverter could fail and the alternator could fail. There's just more things in line, whereas plugging straight onto the battery of your vehicle, really you've only got the alternator that's going to keep on running and going to provide, and alternators don't really fail that commonly. The other thing to bear in mind is when you're using an inverter draws from your vehicle double the amperage that this takes. So if this is drawing 50 amps from your vehicle, because it goes up to 214 down to 12 volts twice, is actually going to, it doubles the amps. I've measured the amperage. If this draws 50 amps, it's taking 100 amps from your vehicle. So it's actually quite wasteful. But they both work. Needs must. You would only use the inverter and the battery support unit if your van doesn't provide a steady voltage. So a lot of the new vehicles with smart charging systems like the VW T6, T7, Transit Custom, the new ones don't provide a steady 12 volts. They have a smart charge. They don't charge basically when they're on idle. They only charge when you brake in and when it's running the battery's low. So it doesn't provide us just a steady voltage. In that instance, that's when you would use the inverter and the battery support unit. Obviously, there's a huge cost saving by just using Anderson connectors as well, because one of these is not cheap, and obviously the inverter is not cheap. You'd need really a minimum of 4,000 watt inverter to run one of these. So you're looking at probably at least £1,000 plus installation costs of running this, whereas Anderson connectors in your grill and some jump leads, you're under £200 to get that all fully functioning, and in my opinion it works far more reliably as well because you've got less to go wrong. But yeah, we'll show you around our two vehicles and we'll demonstrate what we do with them. So this is our Transit Custom. It has an inverter here, 4,000 watt inverter that runs off a leisure battery. When we're driving, the leisure battery charges up, and then when we stop, the inverter will just run off that leisure battery. And if we start the vehicle, it actually then has two batteries and the alternator charging up the batteries, so it provides plenty of power. We'll go through to the back. I'll show you the support unit we'll run. This is a vertical GYS 100 set to 13.5 volts. We have the cables on a carabiner clip there, so it doesn't actually, if we pull it out, it doesn't actually pull it out the bottom of here. It's on that clip, so we can unclip them if we need to, but it just doesn't put any load. And then we have a 15-meter cable on it, so we can obviously support a vehicle a long way away, which, trust me, does come in quite often. The good thing about having a battery support unit is that these are not live until you actually press start on there. So you connect it up to a vehicle, then press start on the battery support unit, and that'll provide obviously a stable voltage for the vehicle you're flashing. We also have on the other side here, if we needed to, a connector there that we can plug in, and that connects straight to the batteries for an emergency use. And I'll show you the other van. So this is how you would connect to the battery. You go straight off the positive lead there. This is a fuse in here, and the wire goes down under the grille into an Anderson connector in the front grille, which just pokes out nicely like that, and you put a cover over it like that. So one side's live, the other side goes off to the chassis. You would just bare off the part of the chassis and connect a lug terminal onto the earth side of it. So here we have jump leads. Obviously crocodile clips on one end, Anderson connector on the other. It's a good idea to connect the jump lead end first, because if you connected that first to your van, these would be live and there's a potential of arcing out. So always connect to the vehicle you're working on first. You want to look for a positive terminal under the bonnet, make sure it's right. So if you make a mistake here, you can cause a lot of problems. So that goes onto the positive, and you're looking for any chassis earth. On here, I want to go down onto the gearbox like so. That's the earth. And then you would come over to the vehicle, plug that in there like that, and then you would start your van up, and then you're going to be supplying the vehicle with 13.5 volts, ready to just maintain it for a flashing process. Hi guys, this is a demonstration of Anderson connectors that look like this. They are 50 amp connectors. They're interchangeable, so they're both the same connector and they're both just clicking like that. There's a positive and negative, said on them what they are. These are 50 amp connectors, but they are rated for 120 amps for 5 hours. So for our use, 120 amp for 5 hours is fine. We're never flashing the car for more than an hour, so that's fine. You couldn't use them at that rating for 24 hours. The rating of a connector is based on its 24-hour use. So these are 50 amps for 24-hour permanent use. They have little terminals like this, and there's all come in different colours. They have little spring connectors in there like that, and you just pop them in and they click into place like that. And to release them, you just bend down on the spring connector like that, and then it just pops out the bottom, and away you go. And we'll show you how to attach it to a wire. You would bear off just the right amount of wire that you need. Like that. Twist your wire up. Like that. And the professional way to crimp that is to use a industrial crimper, which I know no one will have, but here we are, an industrial crimper. That puts a really nice, perfect crimp on that, and it's absolutely solid. Got a lovely crimp. You can then go straight over the top with some heat shrink like this. Pick whatever colour you want, and then you can shrink that down nicely. End up with a nice seal, and then you just pop that in the live one. Like that, and that is now safely located in there. It won't pull out. You do the black one as well, and there's that end connected. To release, again, you would just press down on that little tang in there, and you can actually pull the wire straight back out again. They're a really good connector, Anderson connectors. So that's the professional way to connect to it. There's other ways to do it. My actual favourite method other than that is actually soldering. So you would put this on like this, and then you would heat this up with a blowtorch like that, and then slowly add solder when it's hot into the back side of there like that, which I will demonstrate at the end of this video. But also what you'll have to do is, if that's connected onto the front of your van, for example, this end needs to go through a fuse onto your battery, onto the battery positive. Now, there's lots of different terminals for these, like this. So the terminal sizes is the gauge of wire. So this says 35/8. So it's 8 gauge of wire. Sorry, no, it's 35 gauge of wire, and that's an 8mm hole. So this one is an 8mm hole, 25 gauge of wire. If you can see that there. This one is 16 gauge of wire and a 10mm hole. Yeah, so it depends on what size bolts you have and what you're trying to connect to. But 16 gauge is going to be perfect for this. If you imagine 35 gauge, it's too big, it's never going to seal there. 16 gauge, that's 10, that's too small. 16 here is the perfect size for that. So as long as that fits, you're good. On these ones, you can actually add solder on the top. Make sure you put your heat shrink on first, so you can then solder your joint and then slide it up and cover it. So that would go straight onto the battery positive, through a fuse ideally. You can get fuses in boxes like this, so you'd go up through a fuse in a box like that, and that would go off straight onto the vehicle battery, like so. That's the fuses. So that's one way of doing it. So soldering's my preferred method. Another way is you can just literally chisel it on or in a vise is a good one. So chisel it on there. That's actually not a bad connection there. Not ideal, but you know, it's on there. You could crush it in a vise. I actually think chisel's probably better than a vise because it's actually pinched in the middle. But yeah, let's see if I can actually pull that off. No, I can't pull that off. So that is on. Good. So that's that connector. We'll do a solder joint now for you to demonstrate. So if you don't have an industrial crimper, soldering is probably the best way forward just to get a really solid joint on it. Let's have a look what we've got. So like here, again, you want this in a vise ideally. So it's just going to make a better job. Make sure you put your heat shrink on first, so you can actually slide it up afterwards and make sure it's far enough down so it doesn't get too hot. And you can use a little blowtorch like this, which I recommend you get, or you can use a big one to make it go quickly. We'll go with the little one just because most people have little blowtorches. So you just get it nice and hot. Takes a minute. And then you would just add solder in the top like this. Just keep adding it. You want to do it until you just start to see it coming out the bottom of the joint, which I have just seen. Let's see if I can show you that. So I can just see some silver coming out of the bottom here. Obviously that's red hot. We'll wait for that to cool down. And then, again, you would ideally want to put your heat shrink on beforehand. This is a bit big. Let's see if we've got anything a more suitable size. See if this will go over it. It will. You see, it makes a nice neat job of it. So that's for your Anderson connector, how to crimp it, how to connect it. That is for onto a battery lug or onto a fuse, which I'd recommend you using a fuse. And then you would just do one of red, one of black, pop it straight into your connector. So where does it go? That way. Like that. And there we go. So we've got, obviously, crimp with this. We've got in a vise, or hammer it down with a chisel, which did work really well actually. Or solder. My preferred of all actually is solder. The crimp's really good for being clean, but the solder one is just unbeatable for strength, like nothing beats it. But that is how you're going to terminate and crimp a wire up. And just repeat that for both wires, make sure it's all connected, and away you go.